So in problem 6, we're asked, will I have more money after 14 years if the bank compounds monthly instead of quarterly? So if you remember in problem 5, it took 14 years to turn our $5,000 investment into $10,025, right? So here is the equation you would use, right? If we actually enter this into our calculator, we would get $10,025. Now we're asked if we take the same $5,000 at 5%, but we compound monthly, so we have to change the 4 to a 12 for 14 years, how much money would we have? So here's the new equation. So let's enter this into our calculator and see what the result is. So here's the equation in my calculator. I press enter. And it looks like we're going to have $10,054. So you can see if we compound monthly, we have $10,054. If we compound quarterly, we had $10,025. So by compounding monthly, it looks like we have an extra $29. So again, it looks like the more often I compound, or the greater the number of compounding periods, the more money that I'll actually earn. If we look at question 7, we're asked, well, will I have a lot more money after 14 years if the bank compounds more frequently? Say every day, every hour, every minute, every second? Well, luckily, we don't have to do those calculations. They do the calculations for us down here. And you'll see they change n from 4 to 12 to 365 and so on. And then we're asked to answer some questions. Describe how the amount is increasing as n gets larger and larger. Well, it looks like you earn more money, but as n gets really big, it looks like the benefit is not as great, right? When we go from compounding quarterly to monthly, all right, yeah, there's a difference of about $29. But when we go from hourly to the minute, there's only a difference of 2 pennies between these two values, right? And even daily to hourly, I don't know, it looks like it's about 46 cents or so is the difference. That's not what I would have expected. So yeah, the results are not really what I would have expected. I would have expected as the number of compoundings got really large, that the amount of increase in what I earn would have gotten really large, right? From quarterly to monthly, it increased by $29, and I would have expected if we would have compounded by the minute, the rate of increase would have been way larger than $29, but you can see it really seems to taper off here as we get to hourly and to the minute. And that's actually going to get us to our next discussion. You know, once this n becomes really large, instead of saying compounding hourly or by the minute or by the second, we're just going to say it's continuously compounding. So we're going to need a new formula for that. So if you turn to page 245 in your textbook, you're going to see a formula that says, okay, if interest is compounded continuously, then it looks like we use this new formula here. And again, A is still going to be the current amount, or the P is the principal or the starting amount. The R is your rate. The T is time in years. And this E is the base of this continuously compounded exponential function. So very quickly, I just want to mention this E, where it can be found on your calculator. If you look at your calculator, right above the LN key, see, you'll see this e to the x. So if I press second and e to the x, well, there's my e, and it raises to some value. I'll put in a 1 there. I press enter. So e to the 1 is this 2.718. It's just a number, just like pi, right? If you take a look at the pi key above the caret symbol, right, I press second and the caret symbol, there's pi. I press enter, right? Pi just has a value, 3.14. E can also be found above the division key. Right? If I press second and the division key, there's my E. I press enter. Again, I get 2.718 and change. Okay. So let's go down and go to question number 10. Right? It says historically, investments in the stock market have yielded an average rate of 11.7% per year. Suppose you invest $10,000 now. At 11%, and the interest compounds continuously. So the word continuously is the tip-off, right? Which formula do I use? Do I use this A equals PERT, or do I use the other formula that we saw before? Right? Remember, this formula is only used if we compound monthly or daily or weekly or by the second. As soon as you see the word continuously, we no longer use this formula, and we use this formula, the compound continuous formula. So back to question 10. Well, let's see if we can answer this, all right? Maybe you want to press pause on the video and try and work number 10A on yourself, or by yourself. So this is what it looks like when we plug in the information we have, right? P is what I start with, or my investment, that's the 10,000. The R is the interest rate, that's the 11%. And the 35 is my time in years. So I've entered our equation into my calculator, and I press enter. And it looks like I have $469,930. That's not bad. So there's my result, right? I put in $10,000, I let it grow at 11% per year for 35 years, and at the end, I'll have a nice little nest egg, about $469,930. Part B says, okay, well, what's the balance after 40 years? So all we have to do is change this 35 to a 40, and we'll see what we get. So I've gone back to my calculator, I changed the 35 to a 40, and wow, an extra 5 years, my $469,000 becomes $814,000. So here's my answer. All right, after 40 years, I'm left with $814,509. Part C says your grandfather claimed that 10,000 could grow to more than $500,000 by retirement age, which is 40 years. Is your grandfather correct? Well, the answer is yes. In fact, we know it grows to 814,000, which is bigger than the $500,000 that your grandfather suggested. That's the end of this lesson.